Welcome back to Algebra 1. Remember to follow along with what I'm teaching. You need this book, McDougal, Littell, Algebra 1, written by Ron Larson. It's red with the world on it. Okay, alright, so if you have your book, turn to page 63. But what we're going to be talking about is the real number line. Now, I think the easiest way to learn this is a vocabulary thing. And remember, what makes math hard isn't the numbers, it's the words. So, we're going to learn some words. So, we're going to start with real. But the easiest way to learn what's real is something called imaginary. I always have to think of SpongeBob going, imagination. Now, let me tell you a little bit of background about this before we get to it. And it's that this was not a thing when I was doing this in the 80s. And it's sort of a new thing to math, and I kind of think it's dumb. Just honestly between us. But I'll go ahead and teach it to you because you're going to have to know it for college and Algebra 2. Alright, so square roots, you remember those from pre-algebra, that if you have the square root of 4, this is Arkham Asylum for the criminally insane from Batman. And the only way to get out is to have a twin. So I do a factor tree, and these two factors of 4 is made out of 2 times 2, and they're the same, they're twins. So when you're in Arkham Asylum for the criminally insane, you kill your twin. I know, it's bad, and violent, but they are criminally insane. Okay, and you dissolve the body in acid. I know, it's terrible, but once again, criminally insane. Okay, and then you get in the body bag and zip up and play dead, and then they take you out, and da-da, you're free. So the square root of 4 is 2. Really, you can think of the square root as the opposite of squaring, because 2 squared is 4. The opposite, the square root of 4, is 2. But it's more fun to think about Batman. Okay, so that is a real number. That's what we're talking about. But what about the square root of -4? The only way to get -4 is positive 2 times -2. If it were -2 times -2, 2 negatives make a positive if you multiply them. So -2 times -2 is positive 4. So actually the square root of 4 is plus or minus 2. Because it turns out that we didn't buy the Origin comic for this situation. So we don't know if this 4 is a hero like Batman or a villain like Joker. It's like in Gotham. Jim Gordon got sent to Arkham Asylum for the criminally insane, but he's a hero. So we don't know the backstory. We don't know if this 4 came from positive 2 times positive 2 or -2 times -2. So the square root of 4 technically is plus or minus 2. We'll talk a whole lot more about that later when we get to parabolas. So just kind of think about it that way. But if you had, the only way to get -4 is positive 2 times -2. And these are not twins. If this was money, you got $2. If it's -2, that means that you owe somebody $2. And if it was me, if I have $2, I'm going to the Dollar Tree and I can get 2 things. Probably candy, probably something Reese's. But if I owe you $2, I'm not going anywhere. I'm staying at home. So these are absolutely not twins. Does that make sense? So the answer to what is the square root of -4 is no solution. And that's the abbreviation for solution in chemistry, and we can use it in math too. Okay? So the real answer is no solution. But then along came this guy who was important. Now if I had thought of this, they would say, you are a stupid high school teacher from Georgia. That is dumb. And they would laugh at me. But I knew this was a smart, important person who came up with this, because he sold this dumb idea to everybody. And I think he was a Harvard professor. When I saw it, I was like, I knew it. I knew you were somebody fancy, because if it had been me, it'd be like, no dice. Okay, so this is what he said. Yes, there is no solution, but what if we pretended there is a solution and we call it imaginary 2? So, now we have imaginary numbers. I totally feel like it's the emperor with no clothes on. But imaginary 2 is now a thing. The square root of 4, the answer to it now is imaginary 2. Okay, so what is a real number? R-E-A. What is a real number? It's one that's not imaginary. So any number that's not imaginary is real. And that's what it tells you in your book on page 63, the real number line. It's the opposite is imaginary. Now there's a couple of other ones that we have. One is called rational. And so what's the opposite of rational? I always have kids say unrational. It's irrational. So it's easier, just like it's easier to know what's real by knowing what's imaginary, it's easier to know what's rational by what's irrational. Irrational numbers are numbers like pi. They're numbers that keep going off as a decimal forever without it starting to fall into a pattern of repeats. Pi is probably the most famous irrational number, but if you put in your calculator the square root of 2, the square root of 3, a bunch of other numbers, they will also give you these decimals forever that don't get into a pattern of repeating. So that's what an irrational number is. There's more. There's the natural log one, e, things like that. So how you say what a rational number is things like whole numbers or things that can be written as a fraction. It can be written as a fraction. If it becomes a decimal like this, if you put this on your calculator, you'll get 0.6666. It gets this pattern of repeating, and then the last one on your calculator will be 7. But the reason why is they're just rounding up the next 6. It really is just 6s forever. So it's a pattern of repeating, or it can be written as a fraction, or it's a whole number. All right, so the next one is integer. And integers you think of as whole numbers. They're sort of like the whole numbers. They can be positive, negative, or 0. So integers, my sister said integers. I didn't already tell y'all? I thought she was dumb, but it's a legitimate actual pronunciation. So it could be like -1, 0, or 3. Those are all integers. Now whole numbers are only positive, and 0. 0 is also a whole number. So those are the names of the words, okay? We can put these numbers on a number line, and you probably learned how to do that in pre-algebra. But if not, I can show you how. When you do this for homework, you're going to use a ruler and make it look good. But we can put some numbers on a number line. Alright, there's some numbers to go on the number line. I'm going to change that one to be smaller. I'm going to make it, okay. So, on your number line, the center of it is the origin, it's 0. And then it counts up, and it goes down. This is -1, then -2, then -3. It becomes more negative, so it really counts up both ways, but this is becoming more negative. Alright, so if we were going to put these numbers on the number line, we'd put a dot at 0, couldn't do that one. We'd put a dot at -1 and put it there. 0.4 is positive, but it's less than a half, so I'm going to put it right there. I'm going to mark these off as I do them. There's 3, and here's -2. Alright, numbers on a number line, you put them in order. Usually you write them above, draw a line down to a dot. Sometimes you put them below. Don't try to cram them on the line, there's not enough room to write usually. Right? Numbers on a number line. Next idea is comparing numbers. So, we're going to use inequalities, greater than, less than. I think of this now as Pac-Man. It used to be an alligator for me in elementary school, but Pac-Man is so easy to draw and fun to play. So now it's Pac-Man. Pac-Man wants to eat the one that's more. and whether it's ghost or numbers on the number line. So if we wanted to compare -5 and -4, which one is more? Now this is tricky because the number 5 is more than 4. But you can think of it as which one's better. And it's better to only owe you $4 than owe you $5. So Pac-Man is going to face the -4. -5 is less than -4. Okay? Let's try another one. You could they did it the other way. You could also write it this way. If -4 was on this side and -5 on that side, Pac-Man is still going to want to eat the one that's 4. -4 is greater than -5. What's the sound? Wop, 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 wop. I used to love Pac-Man. Loved playing that game. Then I got it on my phone and it's just not the same. Not as good. I paid money for that app. Not so good. Alright, so I already showed you example 3. Okay, look at example 3. On it, it's got some fractions. 1/2 to put on the number line and -3/2. If you have fractions to add to the number line, go ahead and turn it into a decimal using your calculator. 1 divided by 2 is 0.5. And it makes it a little easier. 0.5 is going to go right there, or you could go, if you know your fraction's good, you can make it 1/2. But like this -3/2, that's -1.5 if you did on your calculator. So I go to -1 and then another half, and there is my -3/2. It's more than -1. So sometimes that helps if you'll do it on your calculator. Example 4, they're comparing distances. Okay. The next idea, and we're going to start talking now about page 65, the opposite. So it's very important in math that you know what the opposite, I forgot to hit start on my timer, that it's important that you know what the opposite of something is. And I bet you already know this. If I ask you, what is the opposite of adding, you would say, that's right, subtracting. And if I ask you, what is the opposite of multiplying, you would say, dividing, right? And also, you can probably figure out that the opposite of squaring is, you don't know what to call it. I think it's called square rooting, but it could be square rootification. Not sure. Alright, but anyway, square root is the opposite of squared. So that's going to be real important as we learn to solve for x. Okay, next idea. That one wasn't bad, was it? See, algebra isn't as bad as you thought. It's even kind of fun, isn't it? Alright, so our next idea is this. Okay, these bars that go up and down parallel stand for absolute value. And how I like to think of them is from the movie Sky High. Have you seen it? It's on the Disney Plus channel. I've had the DVD forever because I love this movie. I can watch it every day and laugh at it every single day. But just in case you haven't seen it, it's about super-powered high schoolers. So and they're learning how to control their powers. And it's great because there's 80s music in it, and like, we're through being cool, we're through being cool, and it's super-powered kids. It's just fun. There's superheroes and villains. It's just really fun. Alright, so in it, not to give too much away, the hero, Will Stronghold, gets in a fight with the guy who we think is the villain at that time, War and Peace. And War and Peace is throwing fireballs, and Will Stronghold is so strong, and they have to go to detention. So they get in a detention room that takes away their powers. The principal, comments away, who was Wonder Woman when I was a girl, and as you might could figure out, I kind of like superhero stuff. I got on my Batman shirt, and have since I was a kid. She puts them in detention, and it nullifies their power. So it doesn't matter if you're a villain like War and Peace, or a hero like Will Stronghold. It ends up where your power or any charge you have on you is taken away. So the absolute value of 5 is 5, and the absolute value of -5 is also 5. No negative sign. It strips it off. Just like the detention room stripped off their superpowers. Okay? But that's not what it really is in math. In math, it really has more to do with the number line. So if I have the absolute value of -3 and the absolute value of 3 -1, -2, -3, okay? That both of these are here on the number line. There's my -3 and there's the 3. The absolute value is the distance it is from that point to the origin, or 0. Now, I like to think it's a frog. You know, it's just more fun. You gotta have fun where you can in math. It's a frog, and it's how many hops he takes to get to the origin. 1, 2, 3. So the absolute value of 3 is 3. 3 frog hops. And if my frog starts here at, that looks like Mickey Mouse. If my frog starts here, or a little like Kermit, at -3, focus, then let's see how many frog hops it is. 1, 2, 3, ribbit. So it doesn't matter if you start at -3 or 3, both of them, the distance to the origin is 3. And that's what the absolute value is. Doop, doop. More fun with sound effects. All right. Because distances are always positive. I don't say it's 4 miles from my house to Kroger and -4 miles from Kroger to my house. Either way, it's 4 miles. All right? So that is section 2.1. Make sure there was a, oh, see, I forgot this is the first time I take this. Okay, the other thing is about absolute values. Eventually, we will solve for x in absolute values. And if you ever get that it's negative something, the answer is no solution, because just like how distances cannot be negative, absolute values cannot be negative. All right, let's see. All right, I think that's good. Y'all, you will read this section and work the problems, but I think we did a good job understanding it. It's pretty easy. Math is fun.